Hi everyone. In this session, we are going to see about logical operators. First of all, what do you mean by logical operator? The logical operators are the operators used to perform logical operators between operands. It means in Verilog, we have three types of logical operators. They are logical and second one is logical or and last one is logical not. For logical and the symbol is double ampersand. And for or the symbol is this. And for not the symbol is this. And now for any operator in Verilog, we have to know the following parameters. These parameters are very important for each and every operator. That is number of operands, number of input bits, number of output bits, and possible combination of output. It means for logical operators, we need at least two operands and number of possible input bits. It means, for example, if I take operands as a comma b, now a can contain n1 bits and b can contain n2 bits. And what are the possible output bits? Number of possible output bits. For logical operators, remember that the outputs are always only one bit, either 0 or x or 1. It means the possible combinations of outputs are 0, 1 or x. Let's see this by simple example. Now if I take simple example, module logical operators which I am taking a comma b as 4 bit. You can take any number of bits. And I am taking output as 1 bit. Now I am assigning a to 4 bit 4 tick b 1010 and b 4 tick b 0101. Now I am displaying the value. Before going to display, now my intention is to show you the logical operator. So for logical operator, the symbol is double ampersand. Now I want to display. So I will use the dollar display dollar monitor. The value of A is, sorry, the value of Y is sentence. Yeah. Now I have given A is equal to 4 tick P 1010, B is 0101. Now how this logical operator will work? Now how it will be evaluated? How it will be evaluated means for a value, whatever the value is given, it will treat it as true or false for logical operators. It means every non-zero value is true. Every non-zero value is true. It means logic 1. Every non-zero is true. It means, for example, how it will become false. Logic 0 is false. See, I said non-zero value is true. It means it is A is non-zero. So it becomes true. And I said B is also 0101. So it is also true. Now, we, we all know that in digital design logic gates, what does the AND gate represents? If A is true, B is true, then output is true. So now I will get output as 1. One more. Okay. Now I will get output as 1. See. Now what happens if I give A as 0? Now the A value is 0. It means it is false. And I am giving B as true. What happens in NOT AND gate? If any one of the input is false, then output will become false. So now output will be 0. See. Now if I give here 40B 101x. Now what happens? In this, if I keep x as 0, it will become non-zero value. Whether it is 0 or it is 1, it becomes, overall A becomes non-zero. So it is true. Now B is also true. So the entire output will be true. See, the entire will be true. Now, if I give 40B xxxx, now what happens this value? If I give x as 0, so it will become false. Now, if what happens if I give x as 1, it will become true. So at a time I'm getting false and I'm getting true. So it will treat it as don't care. Now, if any one of the input is don't care and if any one of the input is true, then the entire output will be don't care. See, hope you understand very well logical operators of logical AND. Now I will explain logical OR. Same, the symbol will be this one. Now what happens? Same, the logical operators are treated as non-zero or 0. Now A will become, what happens if I keep 1010? So now A is non-zero value, so it becomes true. True. And B is also non-zero, so it becomes true. In OR gate, if any one of the input is true, then the output will be true. Yes. Now, what happens if I give here 0? Now it will become 0, false, and it will become true. In OR gate, we know that if any one of the input is 0 or if any one of the input is 1, then with respect to this input only, the output will be evaluated to true value. Yeah. Now what happens if I give here don't care? Now, if I keep x as 0, then it will become false. What happens if I keep x as 1? Then it becomes true. So overall 20th line becoming don't care. Now the B value itself is true. So without considering this 20th line A value, the B value is always true. So the output will be always true value. Yeah. If if I assign B as 0 and if I assign A as don't care, now what happens? In this case, I am getting A as don't care and B as 0. Now, in OR gate, we know that if any one of the input is 0 and it will affected by the other input. It means it will depend on the other input. Now, in this example, B is 0. So, automatically the OR operator will depends upon the A value. It will consider A value. If A is 1, the output is 1. If A is 0, then output is 0. But what happens if A is don't care? It means the X can be 0 or 1. So eventually the output will become don't care. Yeah. Now this is the logical OR operator. Now coming to logical NOT. In logical NOT, we will have only one operand. In logical AND, we will have only one operand. That is, if I take B. Now, what is the symbol? This is the symbol of logical NOT. Yeah. I have taken, yeah, I taken y is equal to logical NOT of B. I am giving B as 0. It means the entire B value become false. So what this 22 line will do? It means logical NOT will do that complement of the input. So B is true. So Y will become false. Now I will get in output as 0. Sorry. It is the B is false. So I will get output as true value. Now what happens if I give a here 1010? It is non-zero value. It means it is true. Now output will become complemented. So output will become false. Yeah. Now what happens if I assign B as don't care? Now can I say this logical, can I say this true or false? If I keep X as 0 or X as 1, eventually B becoming true value. It is non-zero value. So output will become false. Yeah. Now what happens if I keep entire B value as don't care? Now If if I replace x as 0, then it will become false. If I replace x as 1, it will become true. So at a time I am getting true value as well as false value. So the tool will provide this line as don't care. Yeah, don't care. These are about the complete information about the logical operators, logical and logical or logical not. Thank you.